So, good evening, welcome to Sakalavidya Educational Channel. So, welcome to the AP and also Telangana DSC 2024 classes. Today we shall discuss intermediate level chapters, that is matrices. So, already I have completed 2020 series. In the 2020 series we have the concept as well as the level 1, level 2 problems. Today moreover actually in this series we shall discuss easy and moderate and difficult problems, and also concepts will be taught so while dealing with the problems itself only. So, welcome you all. So, Amjad and Ramu Tiksetti, Bejanki Ravi, Ravi Rajaprolu, and all of you welcome to our classes. Right. Let us start our session now. Let us start our session without wasting our time. Okay. This is matrices and determinants. Simultaneously these two we will cover, determinants also. Right. So, first all of you note down the first question. First question. Nagaraju, welcome. What must be the matrix? What must be the matrix X if 2x plus 1 2 3 4 1 2 3 4 equals to 3 8 7 2. So, this is the question mark. So, option A 1 3 2 minus 1, option B is 1 minus 3 2 minus 1, option C 2 6 4 minus 2, option D is 2 minus 6 4 minus 2. So, which is the right option? Which is the right option? This is the question. So, this is simple, just only ordinary level question. This is level 1 question. So, but this question may be given for DSC examination also. Okay. What must be the matrix capital X if 2 capital X plus 1 2 3 4 is equal to 3 8 7 2. So, that we need to find out. So, okay. So, let us try to find out this solution now. Just like solving the equation only, transpose this matrix to this side. So, you will get 2x equals to 3 8 7 2, clear, and minus 1 2 3 4. So, the corresponding elements we need to subtract. 3 minus 1 2, 8 minus 2 6, 7 minus 3 4, 2 minus 4 is minus 2. So, now here take 2x is equal to, we get take 2 common from each element of the matrix. So, 1 3 2 minus 1, 2 2 gets cancelled, therefore, x equals to 1 3 2 minus 1. So, this is the required matrix 1 3 2 minus 1. So, A is the right option. A is the right option. So, absolutely correct. Sivakeshu, Nagaraju, Ravi, Santuraju, Jayalakshmi, Ramu, Tiksetti, Sudhakar. Okay, welcome. Now, let us move to the second question now. Are you ready? Second question. If 3 1 3 2 multiplied with A is equal to 1001, 1001, then A equals to, that means the matrix A equals to, this is the question. So there is a matrix A such that 3 comma 1 3 comma 2 into A equal to 1001, then the matrix A, option A 2 minus 1 minus 3 2, B minus 2 1 3 minus 2, C 2 minus 1 3 2. So option D is 2 1 3 2, 3 1 2 1 3 2. Okay. So now, my dear students, let us say this matrix is B. Now you can write BA is equal to, so this is nothing but identity matrix, 2 by 2 identity matrix I. So multiply both sides with B inverse, so that means B inverse of BA equal to B inverse into I. See, B inverse into B is I, IA is equal to B inverse into I, that is B inverse. Identity matrix is any matrix is A itself only. So A equals to B inverse. That means now as B is equal to 3 1 3 2, so we need to find out its inverse. So how to find out its inverse? See, inverse of, I will give one formula, A is equal to, for example, ABCD. See, inverse of this matrix is equal to, A inverse is given by 1 by AD minus BC into, interchange this first diagonal DA, now change the signs of the second diagonal, minus B and minus C. So in the similar manner, now A equals to B inverse, you need to write, B inverse means 1 by AD minus BC, 3 into 2 6, 6 minus 1 6 minus 3. So multiplied with, interchange the elements of the 3 2. So 2 3, now change the symbol sign of 1 comma 3. So minus 1 and minus 3. So this is equal to, what do you write now here? So now this equals to, you can write now. So this is equal to, what do you write now? So 1 by 3, okay, 1 by 3, this is 2 comma minus 1 minus 3 comma 3, right. BA is equal to I, that's correct. Multiply both sides with B inverse into B is I only, IA is equal to B inverse, so A equals to B inverse, right. B means what? Actually 3 comma 1 3 comma 2. So this is, option is given wrong, you need to change the option. Better change the third option now. Third option, let us change third option. Let us change third option. So that is 1 by 3 of 2 minus 1 minus 3 3. Okay, C is the right option. C is the right option. Yes. So we need to change the options. So now third question. Let us move to the third question now. Third question. Third question. Okay. If A and B, if A and B are square matrices, of same order, and B is a skew symmetric matrix, then A transpose B A is option A, null matrix. So null matrix means each and every element of a matrix is being 0. So B, that is diagonal matrix, and C is a skew symmetric matrix, and D is symmetric matrix, So this is the question, right? So let us try to solve this question now. First of all, read the question carefully. A and B are square matrices of same order, okay, but B is skew symmetric matrix. Then A transpose BA is what kind of matrix? So that we need to figure it out, that we need to find out. So my dear students, first let us so now here first concepts let us discuss. What is the concept means? Suppose A is a square matrix, A transpose is equal to A, then A is called symmetric, A is symmetric. So this is the concept of symmetric. I hope clear. Suppose A transpose is equal to minus A, so then A is called skew symmetric. So and one more property you need to discuss. Suppose A into B into C whole transpose is there. We need to, it follows reversal property. Reversal property means C transpose, B transpose and A transpose. First let us find out transpose of this matrix. So that means first let us apply here A transpose B A whole transpose. Let us try to find out. Reversal law, A transpose B transpose and A transpose whole transpose. And one more property, remember my dear students, properties of transpose. A transpose whole transpose is A. So using these concepts, this we can write now. A transpose you keep like this only, A transpose only, but B is a skew symmetric matrix. B is a skew symmetric matrix means B transpose obviously negative B. So this is negative B. A transpose whole transpose A. So minus of, you can write A transpose B A. So that means A transpose B A whole transpose is negative of same matrix. That's why therefore A transpose B A is skew symmetric matrix. So option is C. C is right option. Absolutely correct. Next others, okay, right. This is third one. So symmetric, skew symmetric, So, this is actually A B C old transpose equal to C transpose, B transpose, A transpose, A transpose old transpose equal to A. All these properties we need to make use of to solve this problem. So, most of the concepts have been covered here. So, next question now. Let us move to the fourth question now. So, fourth question. So, let us try to find out next one. If P and Q are symmetric matrices symmetric matrices of the same order, basically they are square matrices only, same order, then PQ minus QP is, so the product of two matrices P and Q is also a matrix, Q and P is also other matrix. So, the difference of these two matrices is PQ minus QP is. Option A, identity matrix. Option B is zero matrix. Zero matrix, null matrix are same. Zero matrix. Option C, symmetric matrix. D, skew symmetric matrix. Okay. First, all of you look at the question and try to solve it now. So, my dear Ramu, you remember one thing, it is meant for throughout our country because it may be useful for PGT, TGT, even Navodaya also. So, everybody will understand English, they do not understand Telugu. So, that is why it is a universal concept, I need to explain in English itself only. So, if you have any doubt, we can conduct Zoom sessions. During Zoom sessions, definitely I will clarify, I will translate in Telugu language. Right. If P and Q are symmetric matrices, this is very important, this is an important step, of the same order, then PQ minus QP is a what kind of matrix, that we need to find out, figure it out. See, symmetric matrix concept already we know, if A is a symmetric matrix, A transpose is equal to A. So, then A is symmetric, we know this concept, A is symmetric, I hope clear. Suppose A transpose is equal to negative A, then A is skew symmetric. And also these properties you need to remember, A transpose old transpose, AB old transpose, reversal law it follows, B transpose into A transpose. With the help of these properties, so we can find out here. And also one more thing remember, for example, A plus R minus B old transpose is there. So, this also we can write A transpose plus R minus B transpose. So, using these properties, so we can solve this problem now. So, first let us apply transpose to PQ minus QP. So, what is given data, first write down, P is a symmetric matrix, so P transpose is equal to P. Q is also a symmetric matrix, Q transpose is equal to Q. So, we know these two concepts according to the problem now. So, let us apply old transpose, PQ minus QP old transpose. So, this we can write PQ transpose using this property minus QP transpose. It obeys the reversal law, Q transpose P transpose minus P transpose Q transpose. See, P transpose is equal to P, Q transpose is equal to Q. So, this is QP minus PQ. Take minus common, If you take minus common, you get PQ minus QP. So, for example, this is a matrix, for example, say B transpose is equal to minus B. So, therefore, obviously, the PQ minus QP is skew symmetric matrix. So, D is the right option. D is the right option. Yes, not actually here D, skew symmetric matrix is our answer. Yes. So, let us move to next question now. Okay, next question, fifth question. Let us move to the fifth question. Right, are you there now, all of you? Next question, you try to solve it now, figure it now. It's very simple, but moreover try to solve this question now. If A and B are two square matrices of same order such that AB equals to B and BA is equal to A. Then A square plus B square is always equal to this is the stem of the question. So, all of you read the question carefully. Yes, Sumalata, absolutely correct. Fourth option is D. Okay. If A and B are two square matrices means number of rows and number of columns are equal, same order only, such that AB is equal to B and BA is equal to A, then A square plus B square equals to. So, first option, that means option A plus B. This is very important question. Option B, this identity matrix I. Next is 2BA. So, D option is 2AB. Okay, let us try to figure it out, this question now. So, my dear students, remember what do you mean by A square? A square means A into A. Right, you remember this concept. Right. Okay. So, the solution we can do A square plus B square. We need to find out A square plus B square. This A square plus B square you can write A into A. So, in the similar pattern B square we can write B into B. But what is A? A is equal to BA. So, this we can write A of BA. Clear? Plus what is B? Actually, what is B? B is nothing but AB. In the place of B, AB write down. B of AB. But matrix multiplication follows associative property. So, what is the associative property? Means A of BC is equal to AB of C. This is called associative property. It obeys associative property with respect to the multiplication. So, matrices obey associative property with respect to the multiplication, right. So, this we can write again AB of A plus AB of A. So, this is BA of B, BA of B. Again AB is equal to, what do you write now? AB is equal to, you can write AB is equal to BA, because AB is B, BA is A. So, again BA is equal to A plus AB is equal to B. A square plus B square is equal to A plus B. So, beautiful property, you will get it. A square plus B square becomes A plus B. So, you might have understood here we need to apply the associative property, right. Next, sixth question, are you ready? Okay. The value of det of xpq pxq pqx is option A, x times x minus p times x minus q. So, option B, x minus p times x minus q times, so x plus p plus q. C, option C is p minus q times x minus q times x minus p, and option D is pq times x minus p into x minus q. So, this option actually, the two options can be eliminated here by observing. So, first if we find the product of the principal diagonal elements. So, principal diagonal means x, x, x. So, x cube, its degree is 3. Its degree is 3 means option A, x into x, x cube. Okay, option A is also somewhat correct, partially correct. In B option also x into x into x, x cube. But whereas in C option x square, D option is x square. So, C option and D option can be eliminated. These two can be eliminated. Either A or B, that is the answer. In general, option B is the right answer. Okay, how to find out? Let me explain. Determinant of this matrix we need to find out. See, my dear students, let us say delta determinant, delta of, in between two bars you need to write xpq pxq pqx. Here apply C1 is written as C1 plus C2 plus C3. Either row operations or column operations can be performed. See, my dear students, add C1, C2, C3 and write down as a C1, column 1. So, this we can write x plus p plus q. This also x plus p plus q, right? X plus p plus q. Only we are changing C1, remaining are same. P x q q q x. So, one more very important property is there. From any row or any column, the common element can be taken out. What is the common element here? X plus p plus q can be taken common out. X plus p plus q is one of the factor. One of the factor means obviously B is the right option. Without doing further step, we can expect B is the right option. So, the data of this will be 1 pq, this will be 1 xq, okay, this will be 1 qx. Now, apply this time R2 is written as R2 minus R1. We need to read like this. We are changing second row, and R3 is written as R3 minus R1. So already one factor has been taken common out, that is x plus p plus q. See, very beautiful concept this is. 1 pq, see r2 minus r1, 1 minus 1 0, this will be x minus p, this is 0, q minus q. So now this will be actually 1 minus 1 0, so this will be what you have, so q minus p, right, no problem, q minus p and x minus q. Now expand by C1, expand by C1 means only one element, 1 into det of this 2 by 2 matrix. So this is equal to x plus p plus q into, you can write x minus p into x minus q, x minus p into x minus q, minus of q minus p into 0 0. So these are the factors. So x minus p, x minus q, x plus p plus q. So B is the right option. B is the right option. So did you get it? If you understood, write down yes, otherwise write down no. Then I will discuss in the Google Meet sessions. Okay. Okay, let us move to the 7th question now. If A equals to, this is 3 by 3 matrix, 0 x 16 x 5 7 0 9 x is singular, is singular. Singular means inversible, inverse exists. So then the possible values, possible values of x are, same problem can be given in different ways. If A is inversible, then find the possible values of x. If A inverse exists, does not exist, if inverse it is not inversible, then the possible values of x. Option A 0 12 minus 12, option B 0 1 minus 1, option C 0 4 minus 4, option D 0 5 negative 5 or minus 5. So that means very simple. If A is singular, A is singular, this concept remember, A is singular. So A is singular means det A is equal to 0. A is non-singular, non-singular, so that means det A does not equal to 0. So A inverse does not exist means det A is 0, you remember. So now det A is equated to 0. So we get now determinant of 0 x 16 x 5 7 0 9 x. So in order to find out determinant of any square matrix, first of all the priority should be given to the any row or any column which is consisting of more number of zeros. So that is the criteria is to be followed to expand the determinant of any square matrix. So observe here 1 2 zeros are there, maximum number of zeros are present in column 1. So that means expand by R1, this is a mathematical term we use like this, expand by C1. C1 means only this element we need to take, x into. So deleting this row, this column, determinant of x 16 9x, but this sign you need to remember, plus minus plus sign. So that means determinant means here minus x into determinant of 2 by 2 square matrix. So deleting this second row and first column, you have x 16 9x, so equal to here 0. So this is equal to 0 actually, right? So now the here x is, so here we get two cases actually, x is equal to 0 and determinant of this one, x square minus 16 into 9, 144 is equal to 0. So x square is equal to 144 and x is equal to square root of 144. Square root of 144 means plus or minus 12. So 0 plus 12 minus 12. So option A is the right option. Option A is the right option. Okay. So now somewhat one more concept question let us discuss. That is 8th question now. If A and B are two square matrices of order n by n such that a square minus b square equals to a minus b multiplied with a plus b, then which of the following is correct? Then which of the following is correct? Which of the following is correct? So this is the question, right? Option A, either of A or B is zero matrix. B, A is equal to B, they are equal matrices. C, AB is equal to BA, AB is equal to BA. Option D, either of A or B is an identity matrix. Okay. Here A comma B, see A comma B are two square matrices of order n by n such that a square minus b square is equal to a minus b into a plus b. Then which of the following is correct? So that we need to find out. See, the matrix algebra is different from algebra generally, so that we need to proceed here. Okay, this is the question, right? Let us try to solve this question now. See, first consider this one, a square minus b square is equal to what is given actually here, a minus b into a plus b. So distributive property in the right hand side we need to apply. So a into a square you can write, a into b plus ab minus b into a, order should not be changed, ab minus ba minus b into plus b minus b square. Clear? So now if you bring a square this side minus b square this side, this a square minus b square cancel. Obviously we have ab minus ba is equal to null matrix 0. Then only we get a square minus b square. This must be O. So take minus ba this side. So ab is equal to ba. If and only ab is equal to ba, then only in matrix algebra a square minus b square becomes a minus b into a plus b. If ab is equal to ba, we have one beautiful term, ab is equal to ba So that implies A comma B are said to be commute. A comma B are said to be commute, and that means they follow commutative property. So if A comma B are commute means AB is equal to BA given indirectly. So that means actually here C is the right option. C is the right option. So this is the question. Okay, ninth question. If a matrix A is both symmetric and skew symmetric and skew symmetric, then so first option A is diagonal matrix. So B, A is a zero matrix. C, A is scalar matrix. D is A is a square matrix. D, option D, square matrix. Symmetric and skew symmetric means obviously A is a square matrix only, but it's not a correct. D option is not correct. It is always square matrix only. But out of these three, we need to find out. A is a diagonal matrix, A is a zero matrix, and A is a scalar matrix. So my dear students, here matrix A is symmetric as well as skew symmetric. So that means A transpose is equal to A, this equation 1 being symmetric, A transpose is equal to minus A, this is skew symmetric. So now from 1 and 2, from equations 1 and 2, we can write A is equal to minus A. Bring minus A this side. 2A equals to O. A is equal to O. O is a matrix, that means therefore A is a zero matrix. Or we can say null matrix. All the entries of a square matrix are zeros, then only it becomes both symmetric and skew symmetric. That means B is the right option. So most of the concept based questions will be discussed, okay, and also the problematic also we will discuss during our sessions. Right. Let us move to the 10th question. Right. Are you there now? Okay. So let us try to do this question. For how many values of x in the interval that is closed minus 4 comma minus 1, the matrix the matrix 3 x minus 1 2 3 minus 1 x plus 2 x plus 3 minus 1 2 is singular Option A, no value. B, there are two values. C, there is only one value. There are three such values in the interval minus 4 comma minus 1 such that the matrix becomes singular. So this is somewhat actually level 3 problem. Right, try this question. Try this question. Concept is very simple. Equate the determinant is equal to 0, that's all. Then find out the x values, check the x values, whether the x values lie in between minus 4 to minus 1, that's all. Then count the number of such x, that is our answer. So how many values of x? This interval is very important. This is singular. Singular means simply you can write determinant of 3 x minus 1 2 3 minus 1 x plus 2 x plus 3 negative 1 2 equals to 0. So apply the row operations. Apply R2 is written as R2 minus R1. Simultaneously only two operations are entertained. R3 is written as R3 minus R3 minus R1 or R3 minus anything you can do, R3 minus R1. That means from row 2 subtract row 1, from row 3 subtract row 1. So then we get like this now. Okay, wait. So now 1 minute, let me write. R1 is constant 3 x minus 1 2 without changing anything. Now R2 minus R1, 3 minus 3 0. So minus 1 minus x plus 1, minus 1 plus 1 cancel, this will be minus x. X plus 2 x, this will be x. X plus 3 minus 3 x. Next minus 1, same minus x you will be getting. 2 minus 2 0 is equal to 0. From R1 take out x common, from R2 take out x common. So we get now here x square will be common, x square det of you will be getting 3 x minus 1 2 0 minus 1 1, this will be 1 and also minus 1 0 equal to 0. So now expand this one. Now here apply like this. Apply C1 is written as C1 plus C2 plus C3. So 3 plus 2 5, 5 minus 1 4. So this is x square determinant of you will be getting x plus 4, 0 minus 1 plus 1 0, 1 plus minus 1 0 plus 0 0. This is same x minus 1 minus 1 minus 1 2 1 0 equal to 0. Now expand by C1. Expand by C1 means x plus 4 into determinant of this matrix. So you will be getting like this, x square into, So, determinant of this one is minus 1 into 0, 0, minus of minus plus 1 into 1, 1, x plus 4 into 1 equal to 0 you will be getting. So, we get two cases, x square is equal to 0, x plus 4 is equal to 0 means x is equal to minus 4. This is x is equal to 0. 0 does not belongs to this interval minus 4 comma minus 1, but minus 4 belongs to minus 4 comma 1. There is only one value which belongs to this interval. So, C is the right option. C is the right option. C is the right option. Right. So, that means x has only one value, that is minus 4, which belong to the stipulated interval minus 4 comma minus 1. Because closed means minus 4 belongs to this interval, minus 1 also belongs to this interval, but 0 does not lie between minus 4 comma minus 1. So, 0 excluded, only minus 4, only one value which lie between minus 4 comma minus 1. I hope you might have understood. Yes or no? You might be doing, I think so. See, those who will subscribe our channel, they are eligible to chat with me in live chat, otherwise they cannot do it. Right, let us go move to next problem. Right, 11th question. 11th question. If f of x is equal to, det of x cube minus x, a plus x, b plus x, x minus a, x square minus x, c plus x, x minus b, x minus c 0, then option A, f of 2 is equal to 0, B, f of 0 is equal to 0, C, f of minus 1 is equal to 0, D, f of 1 is equal to 0. So, f of 0 is equal to 0, f of minus 1 0, f of 1 is equal to 0, f of 2 is equal to 0. Which is the right one? That we need to figure it out. F of x is the determinant of matrix, that is nothing but a polynomial in x. The determinant of this matrix is a polynomial in x. Then the polynomial values, whose value is 0, that we need to find out. We need to check f of 2 is equal to 0 or f of 0 is equal to 0, f of minus 1 0 or f of 1 is equal to 0, starting with 0 first. So, let us try to find out from f of 0. If f of 0 is not 0, then go for minus 1 or 1 or 2 like that. So, f of 0, instead of x put 0, 0 cube 0 minus 0 0, this will be a, this will be b, this will be minus a, this will be 0, this will be c, this will be negative b, negative c 0. So, now did you have you observed anything here? Yes, your observation may be correct. So, this is nothing but determinant of skew symmetric matrix. Skew symmetric matrix. Determinant of skew symmetric matrix is always 0. So, determinant of this matrix is 0. So, f of 0 is equal to 0. B is the right option. B is the right option. So, I will explain why, because actually you see skew symmetric matrix is A transpose is equal to negative A. So, A transpose is equal to, so minus of negative A here. This is A transpose, det of A transpose is det A only, minus negative A. So, to det A equal to 0, obviously det A becomes 0. This is the concept. So therefore the determinant of skew symmetric matrix is always 0. So that's why f of 0 is 0. So B is the right option. B is the right option. Next 12th question. Next 12th question. Let us move to the 12th question now. Sum of the sum of the cofactors of the elements the sum of the cofactors of the elements of second row of the matrix 1 3 2 minus 2 0 1 5 2 1. Right, this is the matrix. Is option A is 23, option B is 5, option C is 3, option D is minus 23. This is very important question. Very important question. Very important question. See, the sum of the cofactors of the elements of second row in the given matrix. First of all, let us find out the cofactor of the each element of the second row. After that, let us sum of them. Let us add all the cofactors of the second row. So my dear students, first of all, let us write like this. Actually, let us say A is equal to matrix this one 1 3 2 minus 2 0 1 5 2 1. So cofactor of second row first element is capital A 2 1. This is equal to minus 1 to the power of 2 plus 1 you can write, and determinant of deleting this row this column 3 2 2 1. So minus 1 cube is negative, 3 1 ja 3, 3 minus 4. So 1 completed. Next, this element is known as, actually this is second row second column, that is said to be A22. So minus 1 to the power of 2 plus 2 into determinant of deleting this row this column 1 2 5 1, determinant of 1 2 5 1. So minus 1 to the power of even number plus only 1 minus 10, obviously that is minus 9. Cofactor of this 0 is minus 9. Cofactor of 1, that place is actually second row third column A23. So minus 1 to the power of 2 plus 3, 2 plus 3 will be 5, minus 1 to the power of odd minus. So deleting this row and this column 1 3 5 2, 1 3 5 2. So minus of this is 2 minus 15. So minus 13 into minus, so plus 13. What we are asked, sum of the cofactors A21 plus A22 plus A23. So this is equal to, you can write 1 minus 9 plus 13. So 13 plus 1 is 14, 14 minus 9 is 3. So answer is 3. C is the right option. C is the right option. Sorry. 5. So B is the right option. B is the right option. 14 minus 9 is 5. Right. 5 is the right answer. So let us move to next question now. Next question. 13th question. So let us try to solve this question. If A is equal to if A equals to 102 213 03 minus 5 03 minus 5, where Aij is the cofactor of the element of Aij of matrix A, then A21 into capital A21 plus A22, that means element A22 into its product with its cofactor A22, capital A22. This is A23 into capital A23 is equal to value we need to find out. So that means actually here you see the option A is 26, option B is minus 26, option C will be 0, option D is negative 2. Okay, try to figure it out, try to find out this one. That means second row first element, first column, second row second column, that means second row. So that means second row element, actually what we can say that it's the actually the sum of the products of the elements of the second row with their cofactors, that we need to find out. That is the question here. So A21 into capital A21, A22 capital A22, A23 capital A23. So that means A21 means 2. So this row we need to consider 2 into its cofactor plus 1 into its cofactor, 3 into its cofactor. That is our answer we need to find out. Very simple. Whenever you remember like this sign, plus minus plus, for second row minus plus minus, for third row plus minus plus. So you remember this is the sign scheme for cofactors. So for second row, first start with negative. So this is equal to, we get this is equal to, generally say this value is equal to something, anything, say sum S, say S is equal to, you can write A21 means 2, that is actually sign is minus 2 into determinant of deleting this row, this column 0 to 3 minus 5. Now actually plus sign, A22 is 1 plus 1 into, so deleting this row and this column 1 2 0 3 5, 1 2 0 negative 5. So here 3 sign is minus 3 into determinant of deleting second row third column 1 0 0 3. Okay, this is 2 by 2 matrix, 2 by 2 matrix, 2 by 2 matrix. Determinants we need to write minus 2 into 0 into minus 5 0, negative 3 into 2 negative 6, plus 1 into negative 5 minus 0. So minus 3 into 3 minus 0. Let us simplify. Minus 2 into minus 6, 12. This will be minus 5, this will be minus 9. So 12 minus 14. So 14 minus 12 is 2, but negative 2. So our answer is negative 2. So D is the right option. I hope you might have got this idea. Right. Okay. So now let us move to the 14th question. 14th question. If A equals to 1 2 3 4 and X capital X is a 2 by 2 matrix, second order matrix, 2 by 2 matrix such that Ax is equal to I, identity matrix, then x equals to, x is unknown, the unknown matrix we need to find out, then x is option A -2 1 3 upon 2 1 upon 2, right. B is equal to -2 -1, second option, 3 upon 2 -1 upon 2. C 2 1, this is 3 upon 2 -1 upon 2. Option D is -2 1 and -3 upon 2 and -1 upon 2. Okay. So, there is a matrix X such that Ax is equal to I. This is called matrix equation. We need to solve the matrix equation. See, my dear students, remember, so A is a 2 by 2 matrix, X is also 2 by 2, obviously I is also 2 by 2 only. So, Ax is equal to I means directly we can write X is A inverse. Find inverse of this matrix. So, A inverse is equal to 1 by AD minus BC, so 4 minus 6, and adjoint matrix. Adjoint matrix means interchange this row elements 4 1, change the sign of second row. So, -2 -3. So, this equals to -1 upon 2 into 4 and -2. So, -3 and 1. Each element of 4 -2 -3 -1 multiplied with the scalar -1 upon 2. So, -1 upon 2 into 4 is -2. -1 upon 2 into -2. Minus minus cancel 1, you will be getting -1 upon 2 -3, that is 3 upon 2. So, -1 upon 2 into 1 -1 upon 2. So, -2 1 3 by 2 minus 1 by 2, right. So, which is the right option? Which is the right option? Let us check it now. So, now 1 minute, we need to modify. This is -2 and 1, -1 upon 2. So, B is the right option. B is the right option. Okay. Okay, let us try to last question. Let us try to solve last question now. So, 15th question. If A is a non-singular matrix, non-singular matrix means whose determinant is not 0, non-singular matrix, non-singular matrix such that A minus 2i, A minus 4i equals to not 0, this is O, null matrix. So, then A plus 8A inverse is A 6i, B, this is O, C is 3i, D is I. So that we need to find out. So let me read the question carefully. First of all, try to solve this question, all of you. Think about this problem. So what is your answer? See, A is a non-singular matrix. So that means actually here det A does not equal to 0. This is first concept. And one more thing you remember, my dear students, A into I equals to, you get A. And one more concept you must remember, A into A inverse or A inverse into A is I. Enough. With the help of these concepts, this can be solved. So now consider this one. Expand. You get like this. So A of A minus 4i minus 2i of A minus 4i equals to O. A into A square minus 4a, because ai is A, minus 2 into ia is also A. So minus 2a, I into I square is also I. You remember one thing. So I square is also I, that will be plus 8i equals to O. So now this is A square minus 6a plus 8i equals to O. Now A square plus 8i equal to, you can write 6a. Multiply both sides with A inverse. Then what do we get? This is A inverse of A square means A into A plus A 8 into A inverse of I, 6 times A inverse of A. So using these properties, this we can write A inverse A of A plus A inverse I. A inverse into I is A inverse only. So A inverse A is I, 6i, A inverse A, Ia plus 8A inverse is equal to 6i. So therefore I into A plus 8A inverse is equal to, our answer 6i, 6 into identity matrix. So A is the right option. So one additional information to you, this is called characteristic equation. This is called characteristic equation. With the help of this we can find out eigenvalues. Sometimes you may be asked for PGT, TGT examination, eigenvalues also, characteristic or Hamilton equation also this is called. Okay, thank you. We shall meet you in the tomorrow. So far we have completed 15 questions. Once again go through them. So if you have any doubt, every Sunday I will conduct this Zoom meeting. So in the Zoom session we shall discuss your doubts in Telugu. Thank you. Bye bye.